Nanotechnology and nanomedicine are two closely related fields that involve the manipulation and application of materials and devices at the nanoscale level. Nanotechnology refers to the science, engineering, and application of materials and devices with structures, properties, and functionalities that emerge at the nanometer scale, typically between 1 and 100 nanometers. At this scale, the properties of materials can significantly differ from their bulk counterparts due to quantum effects and increased surface-to-volume ratios. Nanotechnology encompasses various disciplines, including physics, chemistry, materials science, biology, and engineering, to understand, manipulate, and control matter at the nanoscale. Nanomedicine, on the other hand, focuses specifically on the use of nanotechnology in the field of medicine and healthcare. It involves the design and development of nanoscale materials, devices, and systems for various medical applications, including diagnostics, imaging, drug delivery, tissue engineering, and therapeutics. Nanomedicine aims to enhance the effectiveness and precision of medical treatments while minimizing side effects and improving patient outcomes. Here are a few key areas of nanomedicine. Drug delivery. Nanoparticles can be engineered to encapsulate drugs and deliver them to specific target sites in the body. This targeted drug delivery approach improves drug efficacy, reduces toxicity, and enhances therapeutic outcomes. Imaging. Nanoparticles can be designed to carry contrast agents for various imaging techniques, such as magnetic resonance imaging (MRI), computed tomography (CT), and fluorescence imaging. These nanoparticles enable high-resolution imaging of tissues, organs, and even individual cells. Diagnostics. Nanotechnology-based tools and devices can be used for sensitive and rapid disease detection. Nanosensors and nanoprobes can detect biomarkers or specific molecules associated with diseases, enabling early diagnosis and personalized medicine. Tissue engineering. Nanomaterials can be used as scaffolds to support the growth and regeneration of tissues. By mimicking the extracellular matrix, nanotechnology facilitates the development of artificial organs and tissue constructs. Therapeutics. Nanoparticles can be functionalized with therapeutic agents, such as genes, proteins, or small molecules, for targeted treatment of diseases. This approach allows for precise drug delivery and localized therapy. Nanotechnology and nanomedicine hold great promise for revolutionizing healthcare by providing innovative solutions for disease diagnosis, treatment, and prevention. However, it is important to continue research into the potential risks and ethical considerations associated with the use of nanomaterials in medical applications.